In this lesson, 2.7, I will show you how to graph a system of inequalities. I will also show you how to complete the practice in Khan Academy. Our objectives are to graph a system of linear inequalities on the same coordinate plane and to identify and shade the solution area. And you can see down here we have an example of a set of linear inequalities that have been graphed and the solution sets have been shaded. And what we are looking for is this overlapping piece, the part that has both blue and orange shading. These points in this solution set will be true for both of my equations, and we'll go over that. The purpose of graphing a system of linear inequalities is for us to be able to write constraints given contextual situations and then graph those constraints in order to figure out the best plan, maybe for producing cars versus trucks, or which business idea will produce the most profit. And we'll get into that in the next couple lessons. So let's look at an example of how we would do this. So here we have a system of inequalities right up here. And the question says, what is the solution of the system of inequalities? Well, you guys already have experience graphing inequalities, and that's what we would do. We would take this first equation and we would rewrite it in slope-intercept form. So we would need to subtract the 2x from both sides right here, move it to the other side, and then we would need to get rid of this negative in front of the y. In order to do that, we could divide through by a -1. But remember, the key thing for you guys, I don't want you to forget, and it's going to be really important when you graph, is that anytime you multiply or divide by a negative number, you need to switch the sign. And that'll be really important because if you don't switch the sign, you won't shade in the correct location. Okay, so I wrote it up here on the top for you guys. Multiply or divide by a negative, switch the sign. And that's what they did down here. If you'll notice that our sign went from greater than or equal to, oops, sorry, we're on the wrong one. Our sign up here went from, well, it did go from greater than or equal to, and now look, it's switched. It's now less than or equal to. So the sign was switched when we multiplied through by that -1. Okay? So first thing first, look at your two inequalities. If you need to switch one to slope-intercept form, that's y equals mx plus b form, go ahead and do that first. Now we have two equations in slope-intercept form. They're easier to graph. So here is our equation that we switched. Y is less than or equal to 2x plus 3. Okay, so remember, here's our y-intercept at 3. This is our y-intercept on the end. Our slope is 2, which is 2 over 1, and it's a positive slope. So I can go down 1, 2 over 1, plot a point, and then we drew the line. We knew to shade on the right side because we wanted all the y values that were less than or equal to this. And the less than is the down below, down here, versus up above. Notice again that our line is solid. If you remember, if we have a greater than or equal to or a less than or equal to, we are going to have a solid line. If we have just a less than or we have a greater than, we would have a dashed line. Okay, so less than or equal to or greater than or equal to, we're going to have a solid line. Now let's look at our second equation, and I'm graphing these on two separate planes, but ultimately we want what's in this third box. So in the second equation, we have a y-intercept here of +1, which is right here. Our slope is a -1 over 2, so we need a negative sloping line from left to right. It needs to go down. So our slope is down 1 and over to the right 2 in order to create that negative sloping line. So now I have two equations. Notice that the second one is also a solid line because it's greater than or equal to. And also one other thing, notice where I shaded above because we want all the y's that are greater than or equal to this. And so that would be up above versus the first one, which is less than, which is below. So I have my two equations, and what you guys are going to do is put those in the same plane like this third example. And you're going to shade each one and look for this overlapping area here. So notice that right in here, and I'll put some lines in here, that is the place where both of my equations, the shading overlaps. And let's put some blue in there too. We've got the orange, we've got the blue. So any point in this crosshatch area will satisfy both of these equations. So if I pick a point, say right here, and that point is at 4, 4, if I plug it into the top equation, it should work. If I plug it into the bottom equation, it should also work. And we'll try that when we graph some. Okay, so this third graph is what you are trying to do. Graph each equation in the same coordinate plane, shade as you normally would, and see where they overlap. Let's try some examples. In our first one, we have x plus 2y is less than or equal to 4, and we have y is greater than or equal to negative x minus 1. This bottom one is written in slope-intercept form, so we can leave that alone. But let's go ahead and rewrite this top one. So our top one we have x plus 2y is less than or equal to 4. I need to move the x over to the other side, so I'll go ahead and subtract x from both sides. And I'm left with 2y on the left side is less than or equal to, I'll write my minus x first, plus 4. Now I just need to divide by 2, and notice that it's a positive 2, so I do not need to switch my sign. And I'm left with y is less than or equal to negative 1 over 2 x plus 2. So I've rewritten my first equation in slope-intercept form. Let's go ahead and graph it. My y-intercept is here at 2, and my slope is negative, so remember I need a line that slopes down from left to right. My slope is rise over run, so it's up 1 over 2. And I look at my inequality sign, it says less than or equal to, so that means I need a solid line. So there's a lot to think about when we are graphing linear inequalities. Okay, and notice that I'm creating a boundary line that goes through the entire plane. That way it'll be easier to do my shading. So I want all the y's that are less than or equal to this equation. Those y's are going to be down below. These are all the y's that are less than or equal to. So when I do my shading, I would shade down here. All right, let's do our second equation. We have y is greater than or equal to negative x minus 1. So minus 1 is our y-intercept. I'll go ahead and plot that. We have a negative slope again, so we need a line that slopes down from left to right. And our slope, and you can't see it, but there is a 1 in front of this, so I could also write this as negative 1x. And negative 1 is over 1, so our slope is up 1 and over 1 as long as I am in the negative sloping direction. And then I look at my sign, and I can see that it is greater than or equal to, so again I would need a solid line, not a dashed line. And we'll go ahead and draw in a solid line here. Now I will need to shade, and it looks like I need greater than or equal to this. So the y's that are greater than or equal to will be above my line, so those will be up here. Okay, so if we look at where these lines overlap, you can see that they are going to overlap in this little triangle region down here. So what I'll do is I'll go ahead and I'll highlight this area so you can see it better. So that's all down here. This is my overlapping region. And just to make sure, I'm going to go ahead and pick a point in that region, and I'm going to test it out in my equations. So let's find a point. Let's see. an easy point would probably be 0, 0. Anytime you can use 0, 0, that's an easy point to plug in. So I am going to choose 0, 0, which is right here, which happens to fall in my solution area. So let's do a test. Let's test and make sure that we shaded the correct area. So we're going to test 0, 0. So what that means is we'll plug in 0, 0 in for x and y, and we'll make sure that the left side of the equation does in fact equal the right side on both of these. Okay, so 0 plus 2 times 0 is just 0. And 0 is less than or equal to 4, so this worked. This is a true statement. Now let's test it in the other equation. So we have 0 is greater than or equal to negative 0 minus 1. 0 is greater than or equal to, well, negative 0 minus 1 is just a minus 1. And 0 is in fact greater than or equal to a negative 1. So this is also true. Okay, and that's our test. We've tested a test point in our solution area to make sure we did it correctly. We have graphed our two linear inequalities. We have shaded the solution area and found the common solution area to both. All right, let's try another example. In this example, both of these are in slope-intercept form. So this would be a good one if you want to go ahead and try this on your own paper first. Shade it, try to come up with the common solution area, and then compare it to this lesson. Okay, if you're just coming back on this first equation, our y-intercept is up here at positive 2, and our slope is a positive 2 over 1, so we need a line going in the positive direction, up 2 over 1. Our inequality sign is a less than or equal to, which means that we need a solid line for this. So we can draw our line in. And again, it's a boundary line, so you want it to separate the plane into two halves. Our second inequality has a y-intercept at the plus 1. So let's go ahead and put 1 here at positive 1. Our slope is a negative 1x, right? If there's nothing there, it's presumed to be 1. So we need a line that slopes the opposite direction in the negative direction. So we would go down 1 over 1. And now be very careful on this inequality. We have a less than sign. So anytime you have a less than sign, you need a dashed line, not a solid line. So we have to make sure that we draw in the correct type of line. And there's our dashed line. So what I've done is I went ahead and I graphed both of these at the same time before shading the solution area. And sometimes that's nice to do because you might be able to determine where they overlap without having to have a lot of shading on your graph. So if I look at the first example, I want all the y's that are less than or equal to my purple one, my purple line, right? So this one is the purple line. I'll go ahead and mark that. This one is the orange line. Okay. Well, all the y's that are less than or equal to the purple line are going to be below. Okay, so I'm just going to keep that in my head. They're all below. And for the second one, the y's that are less than or equal to the orange line are also going to be below, going this way. Okay, so in my mind, then I can start to visualize, well, this is less than the orange line. And it's also up here, but I'm going to hold off shading that because that's not going to be part of my overlapping region. Less than my purple line is also down here. And it's also up here. But again, I'm going to hold off shading that because these solutions would only be solutions for the purple line. Over here, these solutions would only be solutions for the orange line. So if I wanted to, I could shade in here. Especially if this is confusing. Sometimes it's easier just to go ahead and shade what you know, and I could shade here. But you can see clearly that they're going to overlap in this triangle region down here. And that's where my solution set would be. And again, just to be on the safe side, let's pick a point somewhere in this solution area. And I always find the easiest point, if it's in the solution area, is 0, 0, which this one is. Okay, so I'm going to go ahead and test 0, 0 again and just make sure that that point works in both of my equations. So let's test 0, 0. And we'll plug in a 0 for y. Y is less than or equal to 2 times 0 plus 2. So 0 is less than or equal to 2 times 0 is 0, and 0 plus 2 is 2. And this is a true statement. 0 is in fact less than or equal to 2. Let's test it in our second equation. So we have 0 is less than negative 0 plus 1. Well, 0 is going to be less than 1. Negative 0 plus 1 is just 1. So this is also true, and we have shaded correctly. All right, let's move on. All right, we have one more example, and then we are going to work out an example, and I'll show you how to graph this in your Khan Academy practice, which you will try after this lesson. All right, we are looking at these two equations, and I'm seeing that the second equation has a standard form here. We need to write it in slope-intercept form, so let's go ahead and rewrite this. Well, I'm going to add 6x to both sides to move that over. So I'll add plus 6x here. And my new equation, this is gone. I will have 2y is greater than 6x plus 5. Okay, and then I just need to divide everything by 2 in order to isolate my y term. So 2 divided by 2 is gone. And let's go ahead and write it up here. So we are left with y is greater than 3x plus 5 halves. So what I'm going to do with that is I'm actually going to divide 5 by 2. 2 goes into 5 2.5 times. Okay, and remember I'm continuing to pay attention to the number in front of y, because if I have a negative, the sign needs to flip. And so far I don't have a negative. All right, let's go ahead and graph this. So our y-intercept is at 2.5, which is about right here. Our slope is 3 over 1, positive 3 over 1. So we go up 1, 2, 3 over 1. Okay. And I'm going to do another one, 1, 2, 3 over 1, just because I'm using a 2.5 number. And then I will look at my sign. My inequality is a greater than sign, so I know that I will need a dashed line for this. And this is a boundary line, so I'm going to make my line go all the way through and then adjust as needed. Okay, pretty close. My first equation then has a y-intercept of 1. Let's go ahead and put a dot here for 1. And then our slope is a positive 3 over 1. So we're going to go up 1, 2, 3, and over 1. Up 1, 2, 3 over 1. And down 1, 2, 3 over 1. And I'm doing many more points on this one just because I'm noticing that it's very close to this line, and I really want to make sure that I get the right shading and I get an accurate line. So I'm going to do another one, 1, 2, 3 over 1, just to make sure. So on this one, it looks like we need a solid line because our inequality is a less than or equal to. And remember, anytime it's an or equal to, that implies that the points on the line are part of the solution set. All right, let's go ahead and do it in green. And so we can see it better. All right, that's pretty close. And once again, I have not shaded either one yet because I was hoping that I could think about this in my head. So let's look at our first equation here. This is in green. I want all the y's that are going to be less than this line. So that would be all the y's down below, including the line, because it's a solid line. In my second equation here, I want all the y's that are greater than that line. So that would be above the line. So we have a very small solution area. And if you'll notice, all the y's that are less than the green area are going to come here. I'll go ahead and shade the whole thing this time since it's going to be hard to see. Okay, so all the y's that are less than the green are here. All the y's that are greater than the blue area will be up above. So that'll be up above the blue area. So that'll be all these points here. And I know that's not very neat. Okay, so now we just need to really think about where do these overlap. And if you'll notice, it's just a very small sliver right in here. And that's where they overlap, in between the two lines. The blue line goes up, the green line goes down, and it's just right in there. Okay, so it's very, very close. And again, if we wanted to test this, we could get a test point. But let's go ahead and move on to our last equation, and the way we can test it is we can put it into Khan Academy and see if we are correct. And that's what you'll do in your practices. Okay, so here's our final equation. And I would suggest when you do the Khan practices that you write these out on your paper and come up with a y equals mx plus b form, and then we'll go ahead and put it in from there. So if I look at this top equation, this is okay. Y is less than 1/2 x plus 5. We're going to leave that. But the bottom equation is going to need to be rewritten. So let's write it out here, because there's a couple things we don't want to forget when we are rewriting this. So first things first, we need to move the x over to the other side by adding 21x. Add 21x to the other side. So on the left side, we're left with a negative 6y is greater than or equal to 21x plus 18. Now I'm going to divide by a negative 6. So hopefully you are remembering that anytime you divide or multiply by a negative, you'll need to switch the sign. All right, so negative 6, and you need to divide every term by negative 6. So negative 6, those cancel, and I'm left with y. And I'm going to switch my sign is less than or equal to 21x over negative 6. We're going to go ahead and reduce that because it'll be hard to do a rise of 21 and a run of 6. So when I think about what goes into 21, 3 goes into 21 7 times. 3 goes into 6 2 times. And don't forget about the negative that's still there. And then I'll go ahead and reduce 18 over negative 6. Negative 6 goes into 18, negative 3 times. Now I'm ready to graph this. So what we're going to do is we're going to go ahead and go over to Khan Academy, and we'll graph them in Khan. So let's graph the first one because we know that we can graph it just like it is. So we have notice that we have a blue line and a green line. So we have to make sure that we keep them with the right equations. So this is the blue equation, this is the blue line. So we're going to go ahead and pick up this point and we're going to move it over to the 5. And you can slide it left, you can slide it right. Okay. My slope is a positive 1 over 2, so I'm going to take the other point and go up 1 and over 2. Okay, and leave it there. Now, the other thing I need to always consider is the line itself. So after I've graphed it, first of all, make sure we have a positive slope. This is a positive slope. But my line is solid, and when I look at my inequality, it says less than. So I need to change my blue line to a dashed line. Then I need to look at my shading. I want all the y's that are less than this line. Well, it looks like it's shaded correctly at this moment. So the shading goes down and we are in good shape. Okay, now we're going to graph the second equation. So let's go back over and make sure we know what that was. Okay, so I moved over our calculations here on the right so that you can see them. So our equation is y is less than or equal to negative 7/2 x minus 3. So we are on the green equation. I'm going to take the green line and I'm going to move it here to minus 3. So I'm going to drag it over. My slope is negative, so it does need to go in the other direction. This is a positive sloping line right now. My slope is negative 7 over 2, so I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7, and over 2, making sure that my line is sloping in the negative direction. And then I would just double check it. 1, 2, 3, 4, 5, 6, 7, and over 2. Okay, so remember we need to check whether the line should be solid or dashed. And when I look at my sign, greater than or equal to, It should be solid. Okay, when I try to figure out where to shade, I need to look at the y equals mx plus b form. Remember that we flipped the sign, so we want all the y's to be less than or equal to our equation. Well, right now it's shading above, and I want it to shade below. So what I'm going to do is click here on Shade Other Side, and now it's shading below. Notice that in here, this represents our solution area inside this quadrilateral, basically right in here. Okay, so now I think we're ready. We can check our answer. And notice that you only need to get 3 right. So let's check our answer. And we didn't get it right. So there's a couple things you can do when you don't get it right. And we know we only need 3 of these. So we could go ahead and show hints. We could show our hints, and as you click on that, your hints will display down below. You can also watch a video. There'll usually be a con video that you can watch, or we can double check our equations. Well, let's double check the lines. This is a less than, so it is dashed. This one is a less than or equal to, so it is solid. If we look at where we shaded, we want all the y's to be less than this equation, and we are shading down. In this one, we also want all the y's to be less, and we are shading down. But now let's look at our slopes. So in our first example, our slope is positive, right? Up 1 over 2, this is positive. But in our second example, the slope should be negative. It should be negative 7 over 2, and this is not a negative sloping line, this is positive. So what I've done is I've accidentally turned it into a positive sloping line instead of a negative sloping line. Now I can't just do that and say check answer. I need to double check that my shading is correct. So I want all the y's to be less than or equal to this line. And now, because I've switched my line around, it's shading the y's that are up here, that are greater than. So I'll need to go ahead and click on Shade Other Side again. And now our solution set is over here, this quadrilateral over here. So let's go ahead and see if this is the right answer. And now we are good. We are correct, and we can move on to the next question. So there's a lot of things to think about when you are graphing in Khan Academy. You, number 1, need to make sure that these are all in y equals mx plus b form. Number 2, you need to make sure to flip the inequality sign anytime you divide or multiply by a negative. Number 3, you need to make sure that your lines are either solid or dashed depending upon the sign. And then number 4, double check that you are shading the right region. There's a lot of areas to make mistakes in. So as you're going through this practice, if you are unable to get 3, but you've tried 6 or 7 of them, then it's okay to send me a note saying I tried and I got 3 out of 7 correct. I can go into your practice and I can see what you've done. And that concludes our lesson for today.